welcome to CIC Start Online webinar here at Glasgow Caledonian University. My name is Branka Dimitrijević and I will moderate today's event. Our seminars and the webinars disseminate outcomes of the feasibility studies and academic consultancy undertaken by 7 Scottish universities in collaboration with small to medium-sized enterprises in Scotland. The focus of these innovations is on sustainable building design and refurbishment. The project is funded by European Regional Development Fund and CIC program of Scottish Government, which is currently managed by Scottish Funding Council. Just a few event management points. This is a live event, and if it is interrupted by a fire alarm, we will have to stop and continue later. You are welcome to join us later, but if you cannot, you can always watch a video recording of this webinar in a few days. We plan to finish with presentations around 1:30, and online audience can start using chat facility from now to ask questions at any time during the webinar. The questions will be answered after the presentation. The event will close around 2 o'clock. If some questions could not be answered by that time, we will forward the questions to the speakers and they will answer by email. We now offer a live transcription service as part of our online broadcast. The presentation is transcribed live in a pop-up window as the webinar takes place. By providing this service, we hope to make our webinars as accessible as possible. The instructions are provided in a login email that you have received this morning. So, the title of today's webinar is EcoTrip Heating Control Field Trial. This was a study undertaken by Glasgow Caledonian University for Corrour Concepts. Our speakers today are Dr. Charles Russell of Glasgow Caledonian University and Paul Winson of Corrour Concepts. Our third speaker, Gordon Dowie of West of Scotland Housing Association, unfortunately couldn't be here with us today because of the work that he has to do with for the Housing Association. So we'll start with the presentations, and I will kindly ask Charles Russell to give an introduction to this study.
Thank you, Branka. It's a pleasure to be here again, and this time to be talking about the work that we've done with Paul Winson and Corrour Concepts, and unfortunately Gordon Dowie, who couldn't make it today, who provided the field trial conditions for us, site for us. So I'm going to cover a little bit about what he would probably be talking about anyway, and I'll obviously cover some of the results that we got out of the field trial. So I'm going to first of all pass over to Paul, who is the inventor of the EcoTrip, to explain about it and the rationale and give some background to us about that. So over to you, Paul.
Thank you. Hello, everybody. In recent years, heating controls have got more and more clever. Unfortunately, us users of heating controls haven't. Corrour Concepts aims to produce a range of easy-to-use, simple heating controls. And in doing that, we've started with the EcoTrip, which aims to reduce the amount of heat that's being wasted heating our homes when they're empty. I guess that we're all pretty good at turning lights off when they're not wanted. The Scottish Environmental Attitudes and Behaviours Survey that was conducted for the Scottish Government a few years ago found that 94% of people felt it important to turn the lights off, and as you see, 48% say they always do so. So that's not too bad. But then we look at the situation with heating, and the picture changes rather. The number who are down to think it's important to turn the heating off when they're out is below 3/4, and less than a third say they always do so. And we can make a direct comparison between lighting and heating, and the stark reality is shown up. And the fact that people are more reluctant to turn the heating off when it's not needed is really odd. For this reason, let's look at the typical fuel consumption in the average Scottish home. The amount of energy that's expended on heating is around 70%. That's the blue area in the pie chart. The amount that's expended on lighting, on the other hand, is that small slice around 12 o'clock. So, in other words, there's a lot more to be saved by economizing on heating than on lighting. Of course, there are good reasons for this, and perhaps the most important one is that it's easy to turn the lights off and on at the flick of a switch. Not so with heating. So the object of Corrour Concepts has been to produce a heating control that's as convenient to use as the switch, the lighting switch. So let me start with the humble room thermostat, the room stat. The great thing about the device is that the basic thermostat is passive. That means that it doesn't need any external energy source, battery or what have you. And it's self-acting. In other words, when the room stat detects that the desired temperature has been reached, then the device itself operates to turn the heating off. So our objective has been to design the EcoTrip to be as simple to operate as a thermostat. Have we succeeded? Well, perhaps not, but we think we've got pretty close. See what you think. This is the EcoTrip, and what we've done is we have taken a standard room thermostat but linked it with a mechanical countdown timer. And this means that if you're going out for, say, 3 hours, you would want the heating off for perhaps 2.5 hours so that it's nice and warm when you return, and you're able to turn the countdown timer to 2.5. While you're out, it merrily counts back to 0, and if you've got your timing right, half an hour before you return, the heating comes on again and the place is nice and warm when you get back. The thermostat just operates in the normal way, turning it to find a suitable temperature. The timer itself is mimicking, if you like, the thermostat in the way it operates. This is the device as it was realized for this trial. I've got an actual device here, and as you can see, I hope, this is the thermostat, easily set to whatever temperature is comfortable, and the countdown timer can be set in that way. Very convenient. If you realize that you've overdone it, turn it back. If you think, no, I'll be out for longer than that, turn it on again. If you totally change your mind, you can turn it off. So it's pretty simple. The savings from using the EcoTrip are difficult to estimate. So we asked Strathclyde University to run computer simulations and give us some idea of what sort of savings might be made. And their fairly elaborate computer programs were run for two different types of dwelling. The Scottish stock average, which I think was a terraced house, 100 millimetres of loft insulation, and so on. And this is the sort of graph that they were producing. The period for this is the 24 hours, showing the temperature. The upper one is the living area temperature controlled by a room stat. The red lower one is in the bedroom area where thermostatic radiator valves were installed. And in this example, you see the heating coming on in the morning and the temperature rising to the set limit, and then a pause is imposed. At this point, the temperature drops, and then the heating comes on again and heats through for the rest of the day, turning off in the late evening. So they did a lot of work on this, and the results were summarized in this graph. And this shows different levels of saving, the vertical axis against varying pause periods from 0 to 24 hours. The black line is the 1919 poorly insulated house, and the red line is that stock average that I was talking about. So how does this work? Well, if we were to take the 5-hour pause, then you see that looking at the pre-1919 house, for example, the saving is about 2%. So that is on the basis of somebody turning their heating off for 5 hours once a week. For every week of the year, they would save 2% on their annual fuel bill. And the reasons, of course, why you save by turning the heating off is that the temperature drops when you turn the heating off, less heat escapes from the house. As the temperature drops, the rate of loss of heat drops. The heating comes on again, and yes, you start to use up some of the savings that you've already made, but by the simple application of the laws of thermodynamics, you always end up saving more than it costs you to start the heating up again. Something that's not always appreciated by every member of the public. So we, in our own home, experimented with this and found that we were saving about 4% per annum. Obviously, it was a mixture of different pauses at different frequencies over the heating season. But 4% might not sound much, but it compares very favourably, as you see, with what you save by changing from incandescent light bulbs to low energy ones, or the claim savings through using smart meters. So perhaps by this time you're starting to think that this is all well and good, but the EcoTrip looks a bit old-fashioned and clunky. Can't we do something on these lines with an electronic version? Well, Honeywell had a shot at that, and this is their Home Expert, and it's certainly a lot smaller and neater than the EcoTrip. However, it uses 4 buttons and batteries, and it has an LCD screen. And if we make a comparison between the EcoTrip and the Home Expert, then certain advantages of the more basic EcoTrip, I think, emerge. The asterisks relate to bits that I'll elaborate on shortly. But I think the most important difference between the EcoTrip and the Home Expert is this passive feature of the EcoTrip, the fact that it's battery-free. Batteries really are a no-no for many households, particularly in the social housing sector. They had a very bad experience with battery-powered smoke detectors, if you remember. So there are a lot of other things as well that make the EcoTrip usable by the sight impaired and so on, set and forget, and easy to change. Both devices are relatively inexpensive, and yes, the Home Expert does have extra features, but of course with extra features comes more complication. So if we look through these selected items, looking at the setting of the Home Expert, 1 button press followed by a button hold. If you want to change that setting, you then need to make 2 button presses and then a button hold. The EcoTrip can be set to the quarter hour. With the Home Expert, it has to be whole hours. The good reason for that with the Home Expert is, of course, that you press a button to extend the heating period when you're setting it. To extend the off period when you're setting it. And if you had to cycle through quarter of an hour and were wanting to set a 12-hour pause, you'd wait rather a long time. So they only have an hour step to cut down the amount of time you have to stand there holding the button. But of course, the penalty for that is you can't set it as finely as you can with the EcoTrip. Both can be used for cooling rather than heating, but that feature has to be enabled on the Home Expert. And the big advantage of the Home Expert with the complication is that it does have some extra features. So that summarizes the advantages that we see them of the EcoTrip. And we feel that that could certainly help people cut down on the amount of energy they use on heating. Our estimate of that sort of potential saving is based on the 60,000 gigawatt hours that are used in Scottish homes per annum in terms of energy consumption. And we think that 1,000 gigawatt hours are probably spent heating homes when nobody's in. There's no need to heat them. So 1 terawatt is the potential saving. Does the EcoTrip have the potential to drive behaviour change and significantly reduce this wastage? Well, we believe that the simplicity and convenience of the device could do so. Wouldn't you find the EcoTrip handy when you go out?
Okay, well, I'll move on to the field trial section, and a little bit about taking the concept to the reality of it. And I think that there's perhaps a story that could be told about how do you take this concept to actually running it with the field trial. And that in of itself was quite a journey, I think, for Paul in the development of this product. But we're not going to deal with that. Paul came to me with the idea of a field trial and the idea of working with a housing association, and the housing association that turned out to be interested was West of Scotland Housing Association, with particular reference to a project with one of their developments in Cumbernauld. Now, Gordon, who, if he was here today, would explain a little bit more about it, but I'm going to do my best to explain a little bit about the development. So it's obviously social housing. It was built in the early 90s, so it's a reasonably new build. There are 22 housing units. There are a number of mid-terraced and terraced flats that's equal to 32 units. And there are flats in the point blocks, which you'll see the point blocks of the top picture here, the top photograph. These are the point blocks. Just move this up here. Point blocks. These are the terrace. So all these properties are either 1 or 2 bedroom properties. The terraced houses, I believe, are 2 bedroom. And the properties have actually been undergoing quite a lot of energy efficiency upgrades anyway in the last several years, actually, and it's obviously an ongoing commitment by West of Scotland Housing Association that they make the homes as energy efficient and reducing the issues of fuel poverty as best they can. They've had cavity fill insulation in all the properties. That was done in 2007 and 8. They've had an upgrade of loft insulation, so that was the previous year. They've also had improvements to the doors and windows in all the properties, so they are really of a good spec now. The last remaining issue for this development, a curious one, but obviously to do with the way the development was set up at the time, was that all the properties were heated by electric and mainly storage heating until finally a gas supply was installed into the area, and I think that the Housing Association was struggling with the gas companies about actually getting that installed. So these houses have been extremely expensive to heat because of that. The heating upgrade was actually planned, I believe, for the earlier part of the winter, and due to the logistics that often happen, it was delayed, and in fact didn't actually happen until March. So in the original inception of this project last year, we thought that we would have a whole winter to look at, and it turned out that we had effectively 6 weeks really to run the trial at this particular time. However, that said, it was quite something to locate the housing association to find that match, and then to get the EcoTrips into the properties. Now, I just wanted to say a little bit why the housing association was attracted to the EcoTrip. One of the problems that Gordon Dowie finds with installation of these quite modern, you'll see that they're installing these sine combi gas boilers, is often that the tenants will play with the controls, switch them off, switch them on, and often they're dealing with breakdowns with the gas unit, the gas boiler themselves, which is enormously time consuming on their time and resources. And it doesn't leave the tenants any happier. They've got to manage that tenant happiness and obviously keeping their homes warm. So the idea of having this EcoTrip was that instead of switching the heating off at the unit, they could perhaps switch it off for that period of time in their homes without perhaps causing so much damage. That was really the main rationale. I think that's why he really was keen to do that. So we then had a field trial. Now, got to remember that at the same time this field trial was testing EcoTrip, there was also a new heating system for all these tenants, which in of itself, you're dealing with quite a big change in how they experience their heating. However, I want to just discuss what we looked at. The site selection, first thing, site selection process. This is actually really looking at who we looked at. We actually had a total of 10 households that we looked at, and I'm going to then look at the monitoring that we undertook. How did we test how EcoTrip was used and in the sort of situations, and then sort of briefly look at the householder survey to get a sense of who was actually involved in this. As it turned out, the majority of the households were in the blocks of flats, which are 3 stories, 3 and 4 stories, so 4 levels. And we had one other property in the terraced properties that seemed to be a little bit more difficult to get agreement from the tenants about taking those property, about having the EcoTrip installed. However, we got a good range, as you'll see, of different types of people. We wanted to see if it was possible that there was any differences between properties installed with EcoTrip and those without. So they also had all the properties were undergoing the heating change, the heating upgrade to gas combi boiler. And it turned out, actually, we discovered that actually those who wanted the EcoTrip tended to be people that seemed to have more of a need to save money or were more energy conscious because they were high users of energy. So you can see that we have a sort of fairly mixed, from the EcoTrip we have two bedroom houses, flats, 3 one-bedroom flats, and various single males and females included. In the control, a little bit of a variation. We had 1 2-bedroom flat with 2 adults and 3 children, and we had 2 different couples also in this particular set too. Really, we wanted to get as broad a spectrum as possible to try and get a sense of how it was being used. The issue really was in any set development, you are bound to get whoever you're going to get that's going to agree to do the trial, and so we hope that that it was going to be significant enough, but we'll come to that in a minute. So the monitoring, we decided to see if we could take direct measurements and then more looking at how did people experience it, how they're living, that kind of thing. So the first thing that we looked at in the monitoring level was really just direct gas use, which is a meter reading at the start and at the end of the process. We started with the EcoTrip was installed, and some discussion, some instructions were given regarding the use of the device, and so we took the meter readings, both electricity and gas, just to see, because there had been a shift from all electricity heating to gas, just to see if there was any correlation there that we might find. We also looked at room comfort levels. This is using tiny tag data, so temperature and humidity data, just to see how people are living and to see if it's detectable when the heating was switched off. And thirdly, we had a data logger connected to the linked to the EcoTrip device. So if the device was used, it basically told us if it had been switched on or switched off, so we could then work out the actual usage. So just a little bit about that. Maybe just come back to Paul and the circuitry. There maybe not that many people listening who are that technical about this, but we should probably just explain how this was done anyway, so that it's clear. Paul, can I pass that to you as the expert with that?
Yeah, certainly. Yes, the timer that we used had to have the capability of changeover switching in order to be universally applicable to all the different kinds of heating systems. But as it happened in this particular instance at Hillcrest, the system they were using didn't require a changeover relay, and that meant that we had a spare relay in the timer. So we were able to set up the logger so that it used this spare relay and recorded the event when the timer was operated and when it switched on again. So this would give us a very good measure of when and how long the timer was being used.
Great. Effectively, what this meant for me was attaching the two wires to the data logger, so a fairly straightforward installation. We did conduct an early trial with this just to see if it did work, and the indications, the results showed that it did respond. It was the data loggers worked with the system. So we felt confident that this would be a good way forward. So I just want to go through some of the results on the actual energy use from the different sites. So you can see we've got different elements in this table. On the left-hand column, you'll see there's the number of people in the property, and we were looking to see if there was any kind of intuitive things there that we might see, like, for example, if you've got more people in the property, you would have a higher gas use, because it's gas and hot water use, remember. So with these combi boilers, we thought that there might be some kind of correlation. What does seem to be clear from this, which is sort of counterintuitive to what we'd expected, but actually the gas use for the majority, not all, in the households who had the EcoTrip was quite substantially higher than those in the properties that were not, which is probably a case in point in terms of how the properties were selected in the first place, and an issue in the design of the field trial. Also, in looking at the electricity use, there didn't seem to be particularly much of a correlation. You can see that it's all a sort of fairly even spread, that how people are using, and we actually did look and see what, as part of the householder survey, how people were living. So for example, there was the elderly man, maybe have his heating high, but single flat, but then very low, relatively speaking, electricity. So our results for this don't really tell us very much about whether in fact the EcoTrip made a difference in this particular situation. I think we need to be clear about that. But then that's probably part of the design element. Again, so I've looked at in this graph you can see a correlation, to look and see if there was a correlation between gas and electricity use by numbers of people in the household. And perhaps slightly, but it's a very, very weak correlation you can see between electricity use, which is the red. It's less than 0.57, and there seems to be a negative correlation in the gas use. It didn't really tell us very much about that. I think probably individual lifestyles and the range of people in this particular study has more of an influence. Comfort levels, what we can see here, these are the data from the EcoTrip and control comfort, that we call the comfort level monitoring. Effectively, these devices were placed in the living room and left, so they're recording every minute in this case. And what we wanted to look at was to see, is there more variation? Could we see more peaks and drops to see if people were using it? In this particular example, it looks like there does seem to be more peaks in that period. However, the actual results from the data logger were not particularly conclusive, although this particular one, tenant 2, using EcoTrip, had actually used the device, but not for, I think it was a total of 2 hours in a fortnight period. So a little bit inconclusive in terms of that. However, you can see that one of the things is in this particular, this is the third tenant. Now, unfortunately, tenant 3, when the gas installers were installing the flat, they didn't install the wiring for the EcoTrip recorder, unfortunately. However, we did ask if this particular tenant used the device. She said that she had used it. You can see that there are quite clear times when it's been switched off and on. So we need to kind of corroborate that evidence. But again, just gives you a sense of what was measured, temperatures and humidities wise, and it's incredibly variable depending obviously on lifestyle. As I said, with the data logger, we were left a little bit confused with the data logger results. Really only one data logger gave any clear results. We're going to discuss maybe a little bit about that, perhaps why, later. But it did seem that when going back and retrieving the tiny tags, I did ask the tenants if they'd used the device, and they said in most cases they had used it. So they seemed to think that they were using it. The data did not corroborate that, apart from in one. And it seemed that she was using it for fairly short periods. So the evidence there seems to be inconclusive as to what actually happened there. So that really leaves us with that. Then finally, I want to just cover some of the conclusions and some of our recommendations. That we think that the methodology for the assessment was robust enough. The use of the tiny tag, particularly use of the tiny tag, and the surveys seem to be fine, and the meter readings, and telling us how much is being used energy-wise. That kind of overall seems to be all right. And trying to understand householder use of the device is more complicated. So one of the restrictions that we did have was a fairly small sample set, just because of the nature of the study and being a test pilot, really. But what we do know is that all the householders who had the device installed claimed that they used it, but we can't back that up with the evidence. We do have an idea of why that might be, but Paul will maybe come to that in a minute. One of the issues that we dealt with was that the device being installed at the same time as the gas upgrade may have caused confusion, particularly with the use of the timer and the thermostat at the same time. I think that perhaps all of this activity and change at one time could have been quite confusing to the tenants and may have impacted in understanding how to use the device properly. And then of only 5 houses that were assessed, only 4 had the data loggers installed. The trial was actually short. It was a short trial, 6 weeks. We actually started the trial in a heat wave. I don't know if you remember, we had that heat wave at the end of March. It was particularly frustrating, I think, particularly for Paul. I think by that time I was just glad that we were actually going to do something. It did turn cold again, so the heating was used. But the short period of time to really understand, there wasn't really any time to go back and see how they were using it and maybe test it further. So I think probably in conducting this kind of trial over a full winter period, with more households and with more fuller briefing, perhaps even going back after a month or so and just asking them how's it going, and going after things have settled down a bit to show them again could be good. So my final thing is probably further trial needs to be looked at, and perhaps doing it in a retrofit or situation. And I think that's us. Thank you very much, and Vera.
Thank you, Charlie, and thank you, Paul. We already have some questions from our online viewers, so I will start with that. First, a question from Neil Turley of Net Green Development. He's noting pause intervals and asking, how does heavy mass construction, as in Southern Europe, change your assumption? Do you think that heavy mass construction would require different sequences of heating and cooling, and will respond differently if we... That's obviously another study,
yeah.
another research.
Well, there's different elements to this. I think that perhaps when we actually look at it, really there's 2 elements of this, which are, first of all, there's the technical side of this. Does the EcoTrip work as a device that could be used? Second thing is to do with heating control devices and the public's or users' ability to use them, and that allowing effectively savings to occur. So you're linking a number of different things here. So it was ambitious in what we were looking at. And I think, correct me if I'm wrong, I think that what we're looking at here is that it's a device that actually keeps things keep things as simple as possible. So the design, as you'll see, there were many of the people who were had this device installed were either elderly or they were perhaps, let's say for a better word, perhaps compromised or difficult situations that they were living in. So from that point of view, I think this device would be very good. But in terms of complicated different needs and how buildings are, I'm not sure. I think that you might need something a little bit more sophisticated. But then I don't think this device was ever designed for that, to be honest.
Yes, I think it's a very interesting question. Obviously, different buildings have different characteristics. If you have particularly heavy construction, which is absorbing heat and so on, it changes things somewhat. But I would assume the laws of thermodynamics stay the same, and that would mean that there are savings to be made. I would guess that perhaps not so many if you have got thick walls and that sort of thing that retain the heat for longer. But that would be interesting for Strathclyde University to simulate for us and see what result we got. But I don't think the difference overall would be so marked. I think the savings would still be worthwhile.
Okay, thank you. A question from Arthur Prentice of Sandvik Controls Ltd. Aside from the heating not switching back on automatically, why not just switch your heating off when you go out for a few hours? Quite often you don't know how long you are going to be away anyway.
Right, well, fair enough, but what a lot of people do, of course, is that they turn the heating off by knocking the thermostat down, maybe from 20 degrees to 18 or 17 degrees. But there really is a resistance to having the heating set on low and coming back to a cold house. So by knowing that the heating should have come on again if you are returning when you expect to return, it does encourage people, we think, to actually turn the heating off and have it timed to come on again. I do know people who will turn the heating off and just keep their coat on when they get back to their cold home until the heating catches up. But for a lot of people, particularly if they've got young children, elderly people, they want the home to be comfortably warm when they get back. And yes, it is true that sometimes you go out, you're not at all sure when you're going to get back, in which case you err on the conservative side and assume you're coming back sooner rather than later. But certainly our own experience is that we weren't often caught out. And something I should mention as well, that when you got really clever at using this device, you would know that you'd be going out in, say, 3/4 of an hour's time, and you would anticipate going out. You would operate the EcoTrip before you went out, because of course the home takes a little time to become uncomfortably cool. Depends very much on the outside temperature, but we would anticipate things and therefore save an extra half hour or 3/4 of an hour on each occasion.
Here is a comment from Kevin Wood of the Right Track. We have a better option in Canada as to a smart thermostat that learns your pattern when you work and when you are home. That's maybe something to explore, get in touch and see.
Can I respond to that?
Yes.
Yes, I know the sort of advanced things that are being done, and very good they are. And I see that as a substitute for the sort of programmer where you know what your weekly pattern is and you set a different program perhaps for each day, because on one day you are out for longer, and on another day you go to evening class, so you program that into it and so on. And the sort of thing that's being talked about here is very good automation of that. But I defy any system to anticipate when I'm going out, I'm retired, in the winter, have to set the heating to come on in the morning before I get up, go off in the evening before I go to bed. And what happens during the day is highly variable. I might go out walking with friends, I might go out to the cinema, I might go out for a meal. I do get out a bit, so there's no way that any automatic system could anticipate my week. I have no typical week, and that's true of more people than you might think. Yes, a working couple will know that every working day they're out to work by 9 o'clock, they're home by 6 o'clock, and that can be anticipated. But their weekend, do they always go shopping at the same time and to the theatre on the same evening over the weekend? I think not.
Kevin Wood of the Right Track also commented, we also have found that a setback below 15 degrees Celsius has no benefit, as it takes too much energy to get back to 21 degrees Celsius.
Well, that really does contradict everything that we've been talking about. I don't know what the basis of that example is, but in theory, you always save more than you lose through having to regain the heat.
Maybe it is about different type of construction, because this is in Canada.
Yeah, maybe. Because we only looked at traditional housing and pre-1919 housing, so the sort of UK stock, which is obviously different from the Canadian build.
Yeah,
so.
But if I can put it in simple terms, if you want the home comfortable until you leave, and you want it comfortable at the time you get back, then what you are paying for in the interval is the amount of heat that's lost from the home. If you keep the temperature up, or even if you keep it to 15 degrees while you're out, you are going to lose more heat and therefore expend more energy than if you let the temperature drop meantime to maybe quite a low figure, and the heat loss is less in that time. There may be very special circumstances that impinge on that, but I can't think of them.
Another similar comment from Michael Hodgson of Michael Hodgson Consultancy. I think a default to 18 degrees would have been better than off. It would also be good to make the thermostat harder to change. Is that being considered?
Well, I'll answer that question, because one of the things that we found with this, and originally the thermostat did have the same kind of setup as the EcoTrip. One of the things that we found was that they were using the thermostat as they would use a normal thermostat, fairly easy to turn around. And that is damaging to this device. And so that's something that we need to do. The housing, Gordon Dowie advised the tenants, if they were going out, just to be simpler, or they just wanted to turn the heating down, just either turn it down or turn it to 0, and that would turn the heating off. So part of the messaging here, I think, maybe has confused the users. Now, one of the problems that we were faced with was that actually a lot of the people in these houses were finding it too hot with their new heating systems. I know that sounds crazy, but actually they were too hot and more switching it off than switching it on, or worried about it dropping below 18 degrees. So that it was such a new thing for them to have unusually warm homes or comfortable homes that they were switching off. So I think that that's part of trying to understand this. So if you model it from a should be, this is how it would do it in under normal circumstances, that's fine. But this is actually probably quite common with social housing, where you're moving from a set of expectations to something new provided by technology, and then how to make sure that you're not spending too much money. I don't know. That's possibly something that you could look at in the future. I don't think it's within that design though, is it? Right now, do that.
Another similar comment again from Gregor McGregor of Constructive Building Services. Similar questions, Kevin Woods. If the EcoTrip turn the heating off for a number of hours, surely the use of energy would be greater to bring the room back up to temperature than allowing to be thermostatically controlled. It seems that research is required to establish exactly what works better, who is right.
Yes. Well, all I can do is repeat what I said already. Can I use the analogy of the bucket of water with a hole in the bottom? If that's the heating system, and the water running out of a full bucket represents the heat leakage from a house, yes, you're pouring water into the bucket to keep the level steady. If you want to maintain that, then obviously the rate that the water goes in has to be the rate that the water goes out. If you stop pouring the water in the bucket runs right down, and as it runs down, less and less water runs out with less of a head of pressure on it until, of course, the bucket's empty. And then when you want to fill the bucket again, you turn the tap on. And always you use less water in filling the bucket if you let it go in the period you don't want it full than if you try and keep it full all the time. I hope that helps.
A comment from Keith Pierce Design. I cannot help but think that this is a rather simplistic solution that will appeal to a very limited market. In today's world, surely an app interface via a mobile phone to control an entire system would be the way to go.
Well, yes, excellent. If you've got £200 or £300 to spare on the kit, that's beside the cost of the mobile phone, of course, then all well and good. You can turn the heating on when you're coming back remotely using your mobile phone. Things might get a little complicated if you've got several members of the family all playing around with their mobile phones when they're out, but pretty good. However, the sort of people that would, I think, particularly prefer the EcoTrip option are the elderly, maybe the sight impaired, maybe younger people, and a very significant slice of the population who want simplicity, ease of use, nothing complicated, nothing difficult to manage. So I would hope, and our research so far indicates, that there is a market, a substantial market for something as straightforward and easy as the EcoTrip. What we're about here is behaviour change. And the fact that it's there, it's on the wall, it's convenient, it's right by the room stat that you're using anyway. It reminds you, I'm going out, I know I'm going to be out for at least 5 hours, I've turned the heating off for 4.5. That gives you the maximum saving, believe me.
I think so it's very interesting when you talk to the users. And I think somebody who sits in front of a computer and has ideas about how these things could work, obviously we are becoming more technical, and those solutions are much more technical as possible, because that would be the way ahead. When it comes down to it, if you actually go and speak to elderly people, there were a number of elderly people in this trial. Most of them would not want to go near their heating controls. They were terrified if they touched them. Quite clearly, they were worried that if they touched their heating controls, their heating would fail, or they would have to then inconvenience somebody to come out and fix it for them, either somebody from the housing association or somebody they know. So there's that. These are elements that go on that when we as engineers or designers are thinking about it, there's the human interaction with the device. The other thing is that the drivers for these people are they want to save money. Elderly people don't want to waste money, a lot of them. However, their need for heat often is much greater because they're there all the time, or so actually whatever they can save, that driver is there. So £300 may be okay for a professional couple or whatever it is, but that's a different situation for those maybe close to the fuel poverty element. So there's definitely that. The other thing that I noticed was that people's perception about heat and how they keep their houses warm, and this unfortunately is not statistically sound because we only had a small sample size, but the youngest person in the trial had her house around about 3 to 4 degrees flat, 3 to 4 degrees warmer than some of the other elderly people, and seemed to have no compulsion. When I asked her, do you want to, do you worry about heating? Her answer was, not at all. And she would heat her house regardless. And there's these elements of, there's so many other drivers influencing people's attitudes and behaviours behind this that we've got almost to put that into a multivariate analysis. It's very difficult to look at. Probably having something simpler is easier. When I asked everyone, how do you control your heating? Many of them said, I just switch it off. So having this kind of device seemed to be quite aligned with how this particular group of people might go around using their houses or keeping their houses more efficiently.
I might add that it's an incidental benefit of the EcoTrip that if you're thinking of the elderly, they are keen to minimise their heating bill, of course, and will turn the heating off if they think that they can manage it to be cooler for a while. The advantage of the EcoTrip is they would select the period, so they're sitting in their living room, they decide that they're pretty comfortable at the moment, turn the heating off for maybe an hour and a half, 2 hours. Should they fall asleep, should the temperature drop more than expected, at least it comes on again before they get hypothermia. They are doing this sort of thing, turning the heating off when they think they can manage without it. And of course, if it doesn't come on automatically, then that's when they can get into trouble with very low temperatures.
Thank you very much. While we are waiting for other questions, I have a few questions here. So what is next for EcoTrip? What are you hoping to do next?
Well, I would say that the Hillcrest trial has really been, for all its limitations that were imposed on us, quite a useful test bed for the EcoTrip. It's shown up various things that we need to take care of. So now we can deal with those issues and hopefully mount a statistically significant field trial, large number of dwellings. What we need is to find the finance for that. We are incidentally in discussion with Heriot-Watt University here in Edinburgh, who have a major trial that they're designing with 90 homes, and we think there might just be an opportunity to join in that trial, and there might be other options as well. The ultimate, of course, is to get a manufacturer interested, particularly from our point of view, a manufacturer with a Scottish presence, and license to them the production of the EcoTrip.
We have additional comment from Kevin Wood. Sorry, I'm only getting bits and pieces of this conversation to Canada, and I can show you more info on the setback procedures we use in Canada. I do agree that any setback is better than no setback, but the smart thermostat is what should be used. And he also provided a link, hyperlink to the website, so that could be useful to everyone to check how they do that in Canada. Another question, what have you learned from the field trial? What would you do if you were to do another field trial? How would you improve it?
Well, I think there are a number of lessons. First of all, we need to make the EcoTrip somewhat more robust. We were a little surprised by the extent to which some users were none too gentle with the controls. So that's an engineering detail we can easily take care of. We also need to prove the logger arrangement. As Charles has said, we did do a bench test of the setup, which seemed satisfactory, but in practice, although it was a very limited number, the logger wasn't registering in the way we expected. So we need to investigate that. No doubt there are other lessons that Charles would have drawn from that.
Yeah, I think, particularly for it to be statistically relevant, it's fine. I mean, that in of itself is fairly complicated, as studying use of devices in people's houses is not an easy thing, particularly something new. And then to do a large number of them, actually we looked at 10 different households and 5 of them, and a whole range of things happen in people's lives. So there's that. So to have only 5, and that was 6 weeks, and the results of it are variable. So really it would need to be a much bigger study than that. And then I would say, well, perhaps social housing is one area, but maybe we could extend looking out to other different circumstances. I think one of the things that I would like to do, I think quite a lot of this is around messaging and obviously behavior change. People are used to either used to controlling their heating in some kind of way or not. So either they say, well, it's all set by the timer and I don't vary it, or else when I go away I switch it off, or they turn their thermostat down to control it. And here we have a thermostat plus an element which is about switching off. And actually I know it sounds quite simple, but actually the change in that concept of switching the thermostat off to putting the timer on probably is more complicated for people than we think. And probably to look at that, actually to do some testing of that would be quite useful. I think that with behavioral change, which really this is, there's no stick here to really force people to use it. They're going to use it because they want to use it or they see a benefit, and we probably need to show some kind of benefit. So perhaps even making a link so that it shows directly. If we could have a link that shows between the data logger and the energy supplier, yes, a smart metering device, to tell them how much they saved on their bill, would be, I think, a really, really valuable element to this. It may cost a bit, but certainly maybe in the trialing element, that sort of sophistication would probably be needed, because people want to see the proof. And at the moment, we've just got people who are maybe using it, but we need to know the proof.
And how much would EcoTrip cost as it is right now?
Well, the EcoTrip as it is at the moment is assembled from proprietary parts. The cost at retail prices adds up to about £50. That's without the labour of assembly. However, of that £50, nearly £25 is accounted for by the enclosure itself. Now, if this was being manufactured, the enclosure would probably only cost pennies, £1 or so at most. So we would certainly expect that the cost would be on the same sort of level as the Honeywell Home Expert, £35, and I'd be disappointed if it in fact wasn't less expensive than that.
And how did the tenants react? What was their feedback on EcoTrip? What did they say?
Well, I spoke to all of the tenants that had it, and they all said that they used it. I think there was some confusion perhaps about the timer and the thermostat, which we think we've picked up. That's probably what has happened with the ones that failed, as there was one or two that failed and had to be replaced. I think of the two, particularly the two elderly people that had the device installed, they were very positive about that and felt that this was something that was a good thing that the housing association was doing for them, making their controls easier and enabling them to control their heating more easily. So that seemed to be something that they were saying, and it seemed to be generally positive. But you know, it was a fairly short period of time. None of them had even really probably had an energy bill yet, so we were really just taking evidence that we could. So it's perhaps somewhat anecdotal, I think, unfortunately.
Okay, thank you very much. We don't have any more questions coming from our online audience. Anything else to say at the end as a summary, as a comment on your future plans?
What I've been struck by with the questions is this concern about, are you going to save if you turn the heating off? And what I would emphasize on that is that if you look at the simulation results from Strathclyde University, the maximum saving is made in that hard to heat home, drafty, thick walls, all the rest of it, where the boiler really has to struggle to get the temperature back up again. And yet that's the home where there is the maximum saving compared with the average home. So I really think that there is every reason to believe that in almost all circumstances, turning the heating off if you don't need it is better than even turning it down.
Thank you very much. I would like to thank you and to thank our online viewers, but I would also like to attract the attention of our online viewers to our forthcoming event. The next one is a live conference entitled Mass Matters in Low